guys, today we are going to discuss Codeforces Educational round 36 problem D. First I'll explain the problem, then its constraints and solution, and then its complexity as usual. So the problem states that you have been given a graph of n edges, of n nodes and m edges. The graph is a directed graph in which there are edges between u to v. Now the graph is directed as well as there can be some cycles inside this graph. So it's a directed cyclic graph. Cycle may present, may or may not be present. So now we need to find whether it is possible to remove one edge, at most one edge, such that our graph will become a DAG. That is directed acyclic graph. Cyclic. So we can maximum remove one edge to make it a direct acyclic graph. If it is possible to do this, print yes. If it is not, print no. So let's talk about the constraints. Our constraints are n is less than equal to 500 and m is less than equal to n into n minus 1 comma 10 raised to the power 5, minimum of any of this. Okay, so m's maximum value can be 10 raised to the power 5. Now move to the solution. Let's see the constraints first. Our solution can not run in more than, we can have a solution of order of many ways. We can have a solution of order of O of n, even sometimes it works with O n cube, or O of n into m, or O of m log n, or O of m log n. Yeah, okay, that's it. So we can have this kind of solution, or any power of log, like log square and log cube and even. But this is the case where we can have the possible solutions of complexity. So let's think about the solution. Now in our solution, so let's take a graph as 1, 2, 3, 4, 5, 6. It will make, suppose this is this, 3, and this is 5, 4, 3 goes to 4, 4 goes to 5, and say suppose 5 goes to 2. So now if we can see, if you find any cycle in this, say one cycle is this. This is our one cycle, and this is our one more cycle. Okay, so if you take this cycle and remove any one of edge amongst this, you will be able to remove one of the cycles. But will it affect the other cycle? No. So our graph will still remain acyclic. Now, if you remove any of the edges of this, and it will not affect the cycle. So our graph will remain same. So if we can remove any edge of one cycle such that it will affect edge of other cycles, then it may be possible to make it. Or our graph consists of only one cycle. Suppose our graph consists of cycle like this thing. 1, 2, 3, and this is 4, This is our one cycle, and one cycle is like this and this. So it consists of only one cycle, this, and if you remove this edge, will it remove the cycle? No. But if you remove this edge, will it remove the cycle? No. It will make the cycle like this. But if you remove this edge, will it remove the cycle? Yes. Remove the cycle? Yes, it will remove the cycle. Similarly, if you remove this edge, it will also remove the cycle. So, our cycle is this. And if you remove these two edges, there is no effect on the cycle. But if you remove these two edges, or these three edges, you can remove the cycle. So, we need to find whether we are able to remove any edge which can remove the complete cycle of the graph. So, if there are two cycles which are independent of each other, then it may not be possible to remove the cycle. But if there is one cycle or even two cycles that are dependent on each other, we can remove any one edge and then just remove the cycle. So, just say suppose we need to remove, since we need to make the graph as directed acyclic graph, we need to remove every possible cycle. So, if we are able to remove any edge from any cycle, so that cycle is removed and other cycles may be removed or not. Okay, got my point? So, we need to remove the cycles, and every edge, possible edge of that cycle can contribute to the removal of that cycle as well as contribute to the removal of other cycles. So, we need to check for every possible edge of any cycle that removing this will not only remove this cycle but remove other cycles also. So, how can we do it? So, suppose we got this cycle. If you store the edges of the cycle as 1, 2, 3, 4, 5 and this. Now try to remove all the edges and check whether the graph is acyclic or not. First remove this, check the graph. We remove this, check the graph. We remove this, check the graph, and so on. So this way we can find whether removing this edge will allow us to make the graph dark. Okay. So each cycle can consist of, suppose a cycle consists of x nodes. The number of edges in the cycle will be x minus 1. This is how many possible different nodes we have. We have maximum of n nodes. So how many edges we can contribute, like we can remove n minus 1 edges. So for every edge removal, we can check the complete graph of m edges to check whether it is cyclic or not. So what will be our complexity for this case? There are n edges, say n minus 1 edges, and for every edge we are checking for whether the remaining graph is, say we have n minus 1 edges remaining, is cyclic or not, which is of order of n cross n, which is possible. As I said, it will be of order of some 10 raised to the power 5 into 500. It is 5 into 10 raised to the power 7. That will work, easily work. Okay. So our algorithm is just remove every edge and every edge in the cycle, first cycle found, and check whether the remaining graph is cyclic or not. Okay. So how can you find the cycle? How can you find a cycle in the diagram? Simple DFS. You can use a recursion stack to check which elements are in recursion and to check whether a visited element is visited again or not. Or you can use two-color method for finding a cycle, or three-color methods. Anything you know for finding a cycle. To find a cycle. Now store the cycle. store the cycle. So suppose you have stored the edges or the nodes present in the cycle. Now remove each edge one by one, and check whether graph is cyclic or not. It's cyclic graph. Similar to step 1. If it is cyclic, still cyclic, the answer will be no. If it is not still cyclic, the answer will be yes. Now, if you have removed, try with everything and still not able to find this, still not able to remove the cycles, then again no. One more thing, if there is no cycle, if no cycle initially, again answer is yes, because we can remove at most one edge. Okay, so this is the complete algorithm to find this, and the complexity comes out to be, total complexity is n cross m, which will easily pass in n. For complete solution of this algorithm, you can visit our site codeforcessolutions.com, and please don't forget to like it and subscribe this video.